Hello and welcome to this session on event-driven serverless CI/CD for Kubernetes Anywhere. My name is Madhav Sathe and I'm a customer engineer at Google Cloud.
Hi, I'm Abhinav Rau. I'm a principal architect at Google Cloud, and it's great to be here presenting what we worked on.
Thank you. Well, this is a safe harbor statement. Let's take a look at the agenda. First, we will go through the challenges enterprises face setting up the software supply chain. Then we will take a look at the solution that we have built, which is a cloud native choreography for supply chain. And we'll talk about that solution in detail. We'll go through the demonstration of the solution in three parts. In the first part, I will talk about an application rollout, next version of the application rollout and part to production. We'll then talk about a rollout of a bad release or a rollback of a bad release. And in the end, the most exciting part where we show the application onboarding and the experience of application onboarding in minutes using the solution that we have built. So let's understand the challenges first. When you are setting up enterprise standard for software supply chain, your DevOps team will first have to research the plethora of CI, CD, and container tools. Once you pick the right Lego pieces, you have to find a way to securely integrate them to build your supply chain. You will rely on secrets, tokens to bind these Lego pieces together. And that in general increases the attack surface. If you learned about the solar winds, then you know that the build system itself was compromised in case of solar wind attack. And that just indicates that the supply chain itself can be an attack surface. Overall, you're looking at a much higher overhead and cost of ownership over a period of time. There is also a risk of supply chain becoming a monolith, slowing down the innovation. So the whole experience is not geared towards business agility. We first started evolving a solution for our Spring One talk last year. We demonstrated how Gateway API can be used with CI/CD and GitOps to deliver developer productivity. Those interested in Gateway API and using config sync for GitOps can take a look at the recording that we have shown here. Based on the feedback, we decided to ponder on the broader problem of supply chain and app onboarding experience at scale. We realized in order to scale the supply chain implementation, we need event-driven pipelines rather than one big monolithic pipeline. The other aspect, we found that we need a serverless backbone so that the focus remains on business agility and not implementing and managing the supply chain stack. So we went through multiple iterations to design a supply chain that just works as is and can evolve at the same time. So we are happy to introduce Pushpa. It is a culmination of our efforts over last 1 year. Pushpa is a serverless choreography solution for software supply chain. Now there are three important words here: serverless, choreography, and solution. We are implementing this as a solution, not as a product, because we believe that solution can evolve faster than product. Also, we want to avoid the overheads of creating the product or the CRDs that typically people end up doing. Choreography is another important word where we have chosen to use events-driven pipeline, modular events-driven pipeline rather than an orchestration model where your pipeline can become a bottleneck itself. And the other word is obviously the serverless. It is entirely built on GCP serverless technologies. So you don't have to worry about managing infrastructure or data operation concern that we just talked about. I'm sure you want to know what Pushpa means. In Sanskrit, it's a Sanskrit word and it means flower. As many of you may or may not know, anthos is a Greek word for flower. And there is a fun fact about it. Pushpa is also a recent hit Indian movie, and anyone who has seen the movie or has seen the memes on the movie can relate to the fire in the logo instead of flower. And that's where the Pushpa, that's the background of how we came up with the Pushpa brand. So let's take a look at what Pushpa really delivers. At a very high level, Pushpa has two components. One is the software supply chain that we have built fully cloud native on GCP. It's a choreography based software supply chain. And the other is how do you onboard new application on the supply chain? And for that, on the left hand side, you can see there are three inputs. There are target clusters. Obviously, you need to deploy applications somewhere, and we're choosing Kubernetes as our target environment. Then we need your Git repository location for your application code. And since we are implementing GitOps model, we also require your GitOps locations for environment repos. So let's say you have three different environments, dev, test, prod. Then for each environment, we will have a dev GitOps repo, test GitOps repo, and production GitOps repo. This is essentially your application configuration. This is where your application configuration will reside. Let's take a look at the benefits that the Pushpa offers. So why do we think that this solution will actually help enterprises better than something that they are trying to implement? The number one aspect that we think is going to help enterprises is the operational efficiency of Pushpa. It helps you avoid the toil of integrating point solutions from different vendors, which is what you typically end up doing when you're connecting different Lego pieces to create your software supply chain. And application onboarding experience in minutes. So that's a huge advantage when it comes to Pushpa. You don't have to worry about configuring resources or configuring pipelines. Uh, we will help you onboard application in minutes. Security, we talked about it. We gave example of SolarWind attack where build system was compromised and the supply chain itself becomes an attack surface. Since we are using fully integrated cloud native stack, it significantly reduces the overall attack surface of the supply chain. Uh, all the components that we use on GCP use IAM for access control, so you don't need keys or password to access components or integrate between the components. And other aspect here is that since we're using GitOps for all the deployment, there is no need of inbound connection to the cluster. So you pretty much avoid the kubectl apply anti-pattern. So security wise, our Pushpa is built in for better security. Reliability, um, GitOps, all the benefits of the GitOps come into the picture as far as reliability concerned. But there is another aspect that we have taken into account with build this supply chain, design the supply chain ground up, is that to increase the confidence in the supply chain, it is important that you have the ability to roll back features safely and reliably and with consistency. So we have implemented reliable rollbacks to improve the resiliency of the pipelines. If you have a bad release, you can easily roll back. And that actually helps you go faster. The other aspect of reliability is the traceability aspect. How do you find which application version has been deployed in production? How do you find which container version is deployed in production or in staging, etc.? So we have implemented the traceability right from source code to the image to the GitOps configuration, and we'll take a look at that how we have implemented that. And this is the aspect where conformance to the traceability aspects of it to Salsa standards. We will continue to evolve Pushpa to add more and more Salsa features to make it better in this regard. GCP serverless backbone supports Pushpa, so you don't have to worry about scaling the infrastructure. That is the number one thing challenge that we see in the enterprises. We work with the banks and retail customers. Setting up supply chain itself is a major task. Scaling that, managing data operations becomes a major task. So using GCP serverless backbone basically means you can scale without having to worry about data operations. GitOps also helps you, and the config sync and the GitOps will talk about that, helps you use target cluster to the scale of thousands. And the retail edge is a perfect example. And I worked on a couple of such examples, customers. I cannot name the customers right now, but we have worked with the customers where they have thousands of retail stores. So to deliver the software, it can scale to that amount as well. Let's take a look at the open standards and tools that we have used to design and build Pushpa. Open standards, we use it customized for template-free configuration of application. So you don't have to worry about templating or your application configuration. Cloud native build packs is a easier and consistent way to create container images from your source code. So so that you don't have to standardize Docker files or copy paste Docker files as a way to pass on the best practices. We obviously will support the Docker file also, but we think that using cloud native build packs will be a better experience as well as consistent for security as well as consistency. Kubernetes is the target environment. It has become the infrastructure of choice for deploying distributed applications. So that is the natural choice for the target environments. GitOps as a practice that we have chosen, infrastructure as code, pipeline as code. So all of the pipelines that you will see are essentially coming from GitOps, as well as the configuration that we deliver to the Kubernetes is also using GitOps principles. And Terraform, we use Terraform consciously because we feel that most enterprises have Terraform skills. So if you want to change the Pushpa, you can change it using the skills that you already have in the enterprise. So Pushpa can evolve or extend. So Terraform is used to automate the creation of the supply chain for app onboarding experience. As far as GCP Cloud Native Stack is concerned, this is where the serverless part comes in. Cloud Build is a serverless CI/CD tool from GCP. We use Artifact Registry, which supports out-of-box image scanning. And for config sync, or for GitOps, we use Anthos config sync or Anthos config management. PubSub is a event-driven system. So we talked about choreography and how our pipeline is different or how our supply chain is different, fundamentally different than other pipelines or other mechanisms of setting up supply chain is because we use the event-driven choreography pattern rather than orchestration. So PubSub is the backbone of eventing mechanism there. Config sync quick overview. Anybody who knows GitOps will know this, that the Git is a source of truth, and it is the source where it is a location where you describe your desired state of the infrastructure or your applications, and then the GitOps tool will continuously make sure that the runtime state matches the desired state, and we use config sync in that case. So and it can be used with GKE or any of the attached clusters on Anthos. We make heavy use of config sync. So there is a little bit of a pattern here. Config sync supports multi-repo config sync, where the separation of concern is very critical here to drive agility as well as productivity. So cluster level resources or resources that are common across all the namespaces, those are the concerns of the administrator or cluster administrator or operations team. So those are managed in a different Git repository, and per application namespace, we have a GitOps repo. For example, if you want to deliver a foo application, there is a foo GitOps repo, which is where the configuration for foo application will reside. And GitOps or the config sync will continuously make sure that the runtime and state of the cluster matches with the desired state in the Git repo. So the way to deliver any change across fleet of clusters is just to push a new change into the configuration GitOps repo over here. Now let's start building the pipeline. We have a notional pipeline here. Anyone who has implemented a GitOps-based CI/CD pipeline, they can relate to this. What you see here are the resources that are used by the pipelines. The yellow resources, the yellow boxes, they represent the resources based on which the pipeline get triggered. So for example, if you change the code, it will trigger a pipeline, CI pipeline, to build a new image. Similarly, there will be a new feature where we'll support the change of the base image. We have taken into consideration the fact that since it's a GitOps, we also have implemented a pattern of separating the dry configuration from the hydrated configuration. So we use customize for dry configuration. That's a template-free way of setting up a configuration for your applications. So our dry configuration resides in a GitOps repo. The dry configuration repo. And when the new image is available, we hydrate the dry configuration with the image and create a hydrated configuration, which is then pushed to the GitOps repo. And from then the GitOps workflow takes over and distributes that configuration to across fleet of clusters. So that's a very high level overview of the notional pipeline that we have. Now let's start looking at the first part of the demo, where we have a developer who wants to roll out V2 of the application to dev environment, which is our lower environment. So in this particular case, we have just two environments for the simplicity of the demo. We have a dev environment and we have a prod environment. And what we have here is the V1 of the application is currently running in all the distributed clusters that we have. And the beauty of Pushpa is that you can onboard any of the target clusters. Your clusters can be running on GKE, which is what we're going to demonstrate here, but it can be running on-prem or other clouds, or it can be attached clusters such as OpenShift or Rancher or EKS, right? And all of them can be managed using the Anthos control plane, meta control plane, and providing a single pane of glass. So what you see here is the V1 of the application, which is depicted in blue color, and we make heavy use of tagging as a way to communicate what is currently happening to this Docker image. So the blue tag here represents the V1 application code commit SHA for the application code repo, and the orange, the pink, and the dark red or maroon color tags, they represent the environment where this container image is currently running. So since we have only two environments, this image is currently running on both dev and prod. So let's take a quick look at how that looks like in the real application. So this is our application that we're going to use for the demonstration purpose. This is the dev environment. As you can see, we have printed this is a simple web application backed by a Spring Boot API. And we have deployed it across two different environments: a dev environment, which is we have printed some information, metadata information about the cluster nodes. So to help you identify, this is a dev cluster and this is a prod cluster. As part of the code change, our developer is trying to see whether we can change change the background color of this code. So that is what we are essentially going to deliver. As far as the container registry is concerned, I want to highlight here that we are looking at here the full application container images. And if you remember in the presentation, we have three tags for the image. This tag, the first tag, represents the code commit SHA. So if you look at the application code commit, this is the code commit SHA 667D, and it matches the code commit SHA here. So each of the container image will have at least one tag that represents the code commit based on which the image was created. Then there are environment tags that indicate which environments this container image is currently running on. So this same image is currently running on across all our from lower to higher environments, which is what I showed you. So let's take a look at the simple code chain that we want to propagate. I have here my application code, and I'm going to change the background of the web page. I'll pick some color here, maybe beige, beige. So I'll just quickly change it. And I will code commit into my source code repo. So this is my application repo, and I'm going to make the code change here. That should trigger the pipeline. And then we will talk about the process of code commit. Okay, so this will trigger the build image pipeline as soon as we commit the code. As you can see, the Pushpa build image pipeline has been kicked off. Now take a look at the pipelines that we have overall. So when we talk about supply chain essentially in this case is a collection of pipelines that will work together in a choreography fashion to deliver the end result. So we have several pipelines here. The first pipeline that is going to get executed is the Pushpa build image based on the application code change. If you see here, push to a branch, it will use a build pack to compile the code and build a container image and push the container image to the artifact registry. Once the container image pushed to the artifact registry, it will trigger off a couple of other changes, for which I will go back to my presentation and I will try to explain. So we have tag image, then the CD. After the build image is done, then the CD happens, which is a GitHub CD operation. We also use that process to tag it. Once that is done, if your dev environment is, operations team is satisfied, your QA team is satisfied, then you can execute the promotion from dev to prod. And once prod is done, it will also tag the image with prod. And we have also given the feature to rollback. So these are the pipelines based on the environment. If you have one more environment, we'll have one more environment specific pipeline. So let me switch back to my presentation to quickly explain what is happening here. So as soon as we push the code, the first thing that is happening is it will build an image using the cloud native build packs in this case, but you can also bring in your Docker file and do it. It will create a container image, push it to the artifact registry with a tag of the code commit SHA for V2 application that we will see. As soon as that is done, the artifact registry will automatically scan the image for vulnerabilities, which we will later use in the CD operation. And we'll take a look at that as well. And the artifact registry, as we saw, currently has a V1 of the image with all the three tags there. Once the image is published or pushed to the artifact registry, it is integrated with a eventing system, which is a PubSub, and artifact registry will emit an event which has important information that we will use later on. The digest of the image is what we really use to hydrate the configuration. So we use that, and as you can see, we also get a tag which is a code commit SHA, which we will use to tag the image. So this event is published. Once that event is published, next part of the pipeline that is kicked off is the CD part, and the first part of that process is hydrating the configuration. So let's see whether our image is ready quickly, whether that part is done. We'll go to the build history page. Our image is still executing, and oh, the CD part has already started. So right now the build image has been successful. So um, our artifact registry should have a new container image here. Let's quickly refresh this page to see. Okay, so we have a new container image and it has not yet been pushed to any of the environments. So this is the code commit SHA. So 4E56. So if we go here, we should see 4E56. Yeah, 4E56 is a code change that we made 3 minutes ago, and that is picked up for the container SHA. As soon as the CD pipeline is successful, which will happen shortly. In the CD pipeline, as you can see, we first scan for the CVEs. And if there are no critical CVEs, then we will go ahead and start pushing the configuration, which is a CD to GitOps repo, which is what will happen here. So this pipeline will kick in, CD pipeline, which is essentially going to scan for the CVEs. And if there are no critical vulnerabilities, it will push the images to the GitOps repo. Let me quickly go back here and explain what's happening here. In this process, in the hydration process, the event, again, everything is event driven, as I said. As soon as the event is generated, the CD process is kicked off. And in the CD process, it takes the digest from the event, which is the new image digest. And we combine that with the dry configuration, a customized based dry configuration for development environment. And we use customize again in the pipeline to create a hydrated configuration. So we hydrate the configuration, dry configuration with the new image digest, and we check, first of all, we check that for the CVE, and the hydration happens only if there are no high or critical CVEs. As soon as we check that, then we hydrate the configuration and push it to the GitOps repo for dev environment. So this is a GitOps repo. So as you see here, dry repo is different than the hydrated repo. The next process that will happen is, as soon as it lands in the GitOps repo, it will be propagated to all the dev clusters, and irrespective of where that dev cluster is running. So let's quickly check whether our pipeline is successful and whether the image has landed has been pushed to the dev. And the way to look that is simply here. So the image has been pushed to the dev environment, and let's quickly check whether the new color has been propagated. Okay, I think we have to see where this may take some time for the GitOps repo. Okay, so the new color has come in. Okay, the new color has come in the GitOps. So from the GitOps repo, the cluster will pull the latest manifest and then pull the latest container image based on that manifest, which is what is happening here. So if you go back here, this is what is happening. As soon as the GitOps push is done, commit is done, all the config sync across all the dev clusters is going to pull the latest manifest, and then the Kubernetes itself will pull the latest digest from that manifest. And on the sideline, we are also triggering another pipeline that will tag the container image with the dev environment, just to indicate, as we saw, that this container v2 container image now has been uh, rolled out to the dev environment. The next part of the process is to part to production. So we just want to, we are happy with the color change. We have tested the code and we want to now promote it to production. So when we want to promote it to production, again, this is a manual process because it's a business decision. So when the promotion happens, we'll take the hydrated configuration of dev environment, because in the GitOps, Git is a source of truth. So we adhere to that GitOps principle that Git is the source of truth. So we'll find out what is the lower environment, get the hydrated digest from the lower environment, and use the production customize override to create a hydrated commit. After that, the process is all well known that you have already seen here. So let me quickly switch to the promotion pipeline and kick off the promotion pipeline here. Pushpa promote from dev to prod. This is a manual execution. This can also easily be automated, but typically enterprises have a human interface deciding when to go to production. So that is why we have deliberately kept it manual. Uh, but it will trigger a CD process for, yeah, it has kicked up the CD process for promotion to higher environment, and then uh, that will take from there. So let's quickly take a look at, okay, promotion is successful. Let's quickly take out the anthos. So we have these two clusters, dev cluster and production cluster, and they both are config synced. They both are the syncing with the GitOps repositories, the respective GitOps repositories, and these are the GKE clusters and the ingress. So we have a single pane of glass. If you can see, we have the ingresses for a production environment as well as dev environment. So I think the production environment is successful. Let's take a look at the artifact registry. So this prod tag now should move over here for this container image. Let's refresh this page. That has been successfully done. So the production is there. Now let's go ahead and make sure that the production also, okay, this is in the process of perhaps pulling up the latest manifest and replenishing the older version of the container with a newer one. That is what has happened here. So if you see here, the production environment now get a new color as well. Now that essentially brings me to the end of my demo. And let me quickly switch the screen here just to see whether uh,
Yeah.
yeah. So that's essentially the end of my demo. But and as you see here, the tag production tag moving from V1 to V2, which we already saw. Uh, Now, however, there is a little of a dilemma. We got a customer feedback, Abhinav, that the color is not liked by our customers, and now we want to roll back. Like, can you help
Uh-oh.
us?
Okay. Yeah, absolutely. So yeah, so we got to like make the train go backwards now. Now that we've seen that, we could go super fast, but can we go super fast backwards? So how can we do the rollback? So let's look at that pipeline and then kick that off and see how that works. So we're here again back to the pipelines, and we have a rollback pipeline right here. And let's run that rollback pipeline. So you see here, there's some variables, and there's a desired commit value, and this can go back to any commit, but by default, it'll just undo the last one. So we'll run this. And if we go back to our build history, let's refresh this page. And you see that the build is kicked off. And then let's take a look at the bar app itself, prod. So this should go back to our beige color, and we can start pulling it. The rollback has to be what we talked about before. It has to be very reliable, just like promotion was. We need to make sure that as we're with continuous delivery, one of the facets of continuous delivery is that you release your check-in very often. And that means that you're deploying multiple times a day if you have a team of large developers. And that means some people are going to make mistakes. So when those mistakes happen, we need to make sure that we can roll it back. So here, let's take a look at the refresh. So we just have one pod running. That's why you got that little error. But if you have multiple pods, you wouldn't. So take a look. So as you can see here, now we're back at the old color from beige. So it's back to there. So that was rollback. And how does rollback work? It's very similar to what we saw with the promotion. But in this case, since GitOps, since our Git repo, hydrated config repo is the source of truth, we can just revert that commit back. And that will then pull the latest digest. So there's no merging of configs or anything like that in this stage. We just know that the previous one was good, but the latest one was bad. We just need to go back to it, and then config sync does the rest. We're also moving tags here, as we saw. So here with V2, it's going to go back to V1, and we can check that here within the artifact registry. Let's take a look. Let's refresh this. And that's gone back. So now we have dev has the beige color, and prod is back to what it was before. So we saw all that: promotion, rollback, making a new change. And Madhav indicated this earlier in his presentation, is that the real power of Pushpa is how do we onboard a new application in a really, really quick and fast way. So let's take a look how that happens. Let's go back to the code. So here I have Visual Studio Code here, and this is the code base for Pushpa. So it has some cloud build configuration files, but the real magic that's happening to onboard new applications is in the Terraform directory. So here we have a few examples, and this is where this is the Terraform code that we use to deploy the dev and prod environment. But this time we want to install a new application called Bar. Very similar application than a toy application, but it'll give us a sense of how easy it is to deploy onboard a new application. So let's create a new directory here and call it demo bar, and then we'll create a new environment. We'll call it dev, and we'll go into this dev directory. And since there's a very similar applications, we're just going to copy the TF files and modify a few variables, and we should be on our way. So let's paste that here. So we've got it here. The input to this Terraform module is in this terraform.tfvars file. So let's take a look at that. And it's right now it's pointing to the foo app. So let's just change the foo app. Let's just do what developers love to do: search and replace. So we'll go to replace, and we'll say search all with bar. And I already have the bar repo already configured with, instead of foo, it just says bar, etc., etc. So we changed bar everywhere. That's another change we need to do, is that Pushpa also allows you to install config sync if it's not present. But in this case, we want to set it to false because config sync is already installed in the cluster, and we want to go to the dev cluster. And all the input variables, all the configuration and things like that can be done using this file. As you can see, it contains a bunch of configurations that you can change to suit your needs. That's done. So let's save this and let's run Terraform. So those of you who are familiar with Terraform will know we first have to do Terraform init. And then we have to do a Terraform apply. And obviously we use a lot of the modules from HashiCorp and Google. When you do apply, it should tell us how many resources it's creating, and it's going to create all the pipelines. So you can see here, it's creating about 16 resources. That includes all the pipelines. So let's hit yes. and off it goes. So in a few minutes, now we'll have a fully configured pipelines to deploy the bar app to dev. So this is done now. So let's go back to our console. Let's go to our triggers, and let's now filter by the bar app here. So it's still empty. So let's refresh this page. So the filters come back. Let's do tags. So we have the bar app. So now we've got the pipelines. And let's make sure, since we don't have anything deployed yet, let's kick off a build so it deploys. So let's go to the bar app. So this is the bar app code repo. And we'll make almost the same change that we made, that Madhav made earlier. So let's go to the properties file. Let's modify this. And I like the color pink because my browser's pink here. So let's change it. So we'll save it. And now we should get a pipeline that's kicked off because we've installed the pipelines already for the bar app. So I'm just going to refresh this so that the trigger name is refreshed as well. So as you can see now, the bar app, its CI/CD process has kicked off. So let's talk about what the challenges of this are. Correct. So you might have noticed there are multiple pipelines there for a reason, and they're all there to have a specific purpose. All these pipelines are watching the input resources and are triggered based on events generated by those resources. So we saw events, a code commit, whether it's a tagging, whether it's a commit to the GitOps repo. And this is what makes the entire supply chain choreography based. Because we're looking at PubSub, we're looking at Git commits, we're making sure that that all these things are aligned. We're also, config sync is watching for those changes as well. And we're also watching for changes in artifact registry. So whenever an artifact registry tag is updated, PubSub is doing that eventing. So each pipeline, and the advantage of this is that each pipeline is designed to do only one thing and one thing very well. So sticking with that kind of premise, it works very well for software. So each pipeline can also evolve independent of others. So there's no tight coupling between the pipelines. And each pipeline changes the state of the output resource, which further generates events. And here, the important part here is that we've consciously avoided creating yet another, Kubernetes resource or a CRD resource that you have to install and choreograph and manage. We're using practices already familiar with DevOps personnel like Terraform, so that they can get productive really quickly. And since it's a solution, not a product, it can evolve much faster. However, it does take some time to set up these pipelines, because there is some wiring to do. And you can see here, there's all the number of pipelines that needs to be created. So in this particular instance, we're showing dev, test, and prod. And you can see the number of pipelines can easily get out of hand once you have a number of applications. So how are we going to set up all these, right? Are we going to do them manually? No, of course not. We're going to automate everything. And that's what we saw when we did the using Terraform. We onboarded an application in less than 2 minutes. So let's take a look at, again, here, Madhav showed this diagram about how we're taking a few inputs. But what we didn't tell you is that we've also combined it with Terraform. So Pushpa has Terraform modules that actually make creating these pipelines is not only the design of the pipelines that we've come up with, but we've also made it so easy to adopt, lowering the barrier to entry. So let's first take a look at, kind of summarize what we saw. We saw that the industry is looking for more repeatable solutions for continuous delivery. And as the number of applications are increasing due to the adoption of microservices, so is the need for tools to automate the path to production. And legacy monolithic pipelines have several limitations and risks when it comes to security. As we saw with the SolarWinds attack, the build system itself is a target, and a highly integrated and secure build system is much better from a security posture perspective. And we have a faster onboarding experience. We have a smaller attack surface. Moreover, the backbone of Pushpa is fully backed by GCP's managed services, so you don't have to worry about scalability. Now, why is scalability important for a build system? It's because once you have a number of applications, a number of pipelines increase, and the number of developers on a team increase, number of commits increase, then there is a certain load on the CI/CD system itself. And I've personally seen where that can become a bottleneck when the organization is growing. So you don't want to be managing, another resource where now your CI/CD system is becoming a bottleneck to deliver for your business. So now that we reviewed, let's take a look at what happened with our pipelines. So it looks like the bar app succeeded. So let's take a look at the ingress over here and refresh this. Let's see if our bar app is created. So it looks like the ingress is still being created. So it takes some time for that to happen. But let's take a look at artifact registry. And we have to go to the bar app, the bar image, the foo one. So we can see that it has been tagged with dev. So that's working, which is great. We'll refresh again, and let's try to hit the endpoint. So it looks like it's still building that load balancer. But let's come back to this. Hopefully, it'll be done when we come back. So what are the next steps? Before that, I'd like to leave you with a haiku, and this is maybe some people will relate to this. If you had to summarize Pushpa in a few words, it would be with a haiku. It would be: here's my code. Set up my supply chain for all my clusters. I don't care how. And you saw a little glimpse of that, a flavor of that, when we onboarded the bar application, where really the barrier to entry has been significantly lowered with that highly integrated solution that can also be set up in minutes. So what are the next steps for Pushpa? We're still ironing out some of the edge cases. We're still validating our design. We wanted to share this with you to see if there is interest in actually discussing some of those issues and how maybe Pushpa can solve some of them. And reach out to us if you find that this solution is compelling, and we'll be happy to get back with you. Or reach out to your Google Cloud representative as well, and they can help as well. So that's what we have. Let's go back and see whether our ingress has been created. Looks like it's still taking some time.
So while this is being created, Abhinav,
Yep.
like I'm really fascinated about the fact that the whole supply chain can be set up for a new application in really minutes and without depending on any CRDs or anything, creating multiple layers of complexities. So I really like that fact. Can you tell us a little bit of a background how we evolved this solution for the last 1 year, like how we started and like what triggered us to add features that essentially uh, led to creation of Pushpa?
Yeah, that's a great way to kind of describe how this evolved. Originally, it started by both of us who paired on a presentation for Spring One, as you mentioned earlier. And we were going to do a presentation on the Gateway API. And if you haven't checked out that video, please do. It's on YouTube. And we used GitOps to deliver some of those configurations. And then I think after that, we realized that we really struggled with setting up a good pipeline for GitOps. and we wanted to research that further and say, hey, what is the barrier to entry for GitOps? Everyone knows we should be doing that. Enterprises should be doing that, and that's what led us to this. And then originally we were planning to do a very simple proof of concept of getting these pipelines and designing them and documenting them. But then we also ended up realizing that creating these pipelines would take a lot of time and effort and toil to create them manually. So that's what led us down the line. What has your experience been in this?
Well, I think the journey has been fascinating as we never really planned to have a solution as sophisticated as this when we started out. Our plan was to show a developer productivity using gateway API. So we made use of the traffic splitting functionality, and we married that with the cloud build and GitOps. So three things to put together: the cloud build as a serverless CI/CD, GitOps config sync and GitOps for delivery, and gateway APIs, traffic splitting as a way to deliver uh, applications gradually into production. That pipeline was good, but it also meant that the pipeline had some imperativeness to it in terms of execution, not in terms of deployment. The deployment was still GitOps. But when we started scaling out, we realized that if you want to scale it for maybe hundreds of applications or maybe thousands of applications, we need a way to create pipelines that can adapt to environments that the enterprise will really have. Like enterprise is never going to have just one environment. They're going to have layers of environment. And some of the banks that I work with, they have 4 layers of environment like dev, test, performance, and prod. Like how do you solve the problem for a scale of a major bank or a major retail giant? For that is important to have an approach that will help us evolve the pipelines and add functionality to pipelines independent of each other. And that led us to creation of choreography pattern and events driven pattern. So we made sure that none of the pipelines are imperatively calling each other, and each pipeline, as you described in your summary, that each pipeline is responsible for one task alone, and it does that one task really well. That means that we are watching the input resources, and any state change in that input resource will trigger an event, which is how event driven microservices are used for a long time now. The ecosystem, whole PubSub ecosystem, or Kafka or RabbitMQ, the event driven ecosystem of microservices has evolved precisely because of this reason that making an imperative calls slows down, creates too much of tight coupling, slows down the innovation. So having a loosely coupled microservices can independently evolve and independently scale also. So that is the idea that which we eventually led to, that hey, if you want to scale the pipelines, why do we have a monolith pipeline? And there are some open source projects that are evolving to adopt this choreography pattern. So we have a little bit of a validation that we are not the only one who are doing this, but we have advantage over the other choreography pattern implemented by open source called cartographer, that we have native implementation on GCP, cloud native implementation. So our stack doesn't rely on third-party pipeline tools. You don't have to write Jenkins or Tecton pipelines and then manage those somewhere else. It is all running on GCP cloud native serverless
Right.
system. So the backbone is serverless. So I
Yeah.
think overall combining the design philosophy, that sticking, adhering to the event driven choreography pattern, adhering to the GitOps principle that Git is the source of truth. So we use that even in our promotion. So if you remember the promotion pipeline from dev to prod, it uses the hydrated lower environment repository and dry configuration for the higher environment. So lower environment, it will take what is there, the source of truth, what is currently running in lower environment, combine that with the dry configuration of the higher environment to create a GitOps configuration for higher environment. So adhering to some of these principles uh, is something that I personally liked about. And obviously, what you demonstrated is really fascinating. That you just created a new application within minutes,
Absolutely.
and then have a pipeline delivered. Maybe can you check whether your load balancer is created, and maybe you can show the application with live colors.
Yep, yep, it is live now. So, yep,
Can you
we've
show
got it.
that? Yeah.
So I've got my pink color showing.
Oh, wonderful.
So yeah, so it just took a little
Can you
while.
increase the font a little bit on the browser?
There we go. Yeah,
Yeah. So this is running in dev cluster in this. So you're using the same target environments, but you onboarded a different application, its
yeah,
own namespace.
yeah. It's the same app, but just modified. It's a toy
So
app that we
yeah,
had. Yeah. So yeah, we do have a question
yeah.
Q&A. So I'm gonna ask
Is
that.
there is there a way to automate tests after cloud run, um, build, which can perform multiple series of requests and prevent new instances going live to production unless they pass? Yeah, of course. So we have only taken into account the image creation part, but the CI will typically include multiple steps to do various tests. And I personally am not a good test engineer, so we haven't included that in the demo. But certainly, the whole idea of the CI is that the image will not, we can put those guardrails like image will not be published to the artifact registry unless the test pass. Or for promotion, we can we have deliberately included promotion as a manual just precisely for that reason, because we think that the promotion should be a business decisions. But promotion to prod can be a business decision. Promotion from dev to test can be automated based on the passing of the tests. So all of those things can be checked within the CI pipeline, and only that the image creation can be published. So yes, all of those the pipeline itself, the Pushpa itself can evolve.
Yeah. I would add to that that we didn't have any checks like GitHub checks. Right now, Pushpa supports GitHub, and so we didn't add any checks to whether whether that checks pass, and then you can run the actual CD process. So or the commit to Git process. The build image process obviously will happen. You just store it off for artifact registry, but then you could have the CD process run, some validations, and then you could see the results in GitHub itself. So Cloud Build has that integration, so you could build it as a pre-check to run the next pipeline. So that's possible to do. It's just that we didn't do it in this part. We just um, focused on the actual delivery part and not the CI part. But absolutely, you could do this for Cloud Run.
I
Um,
don't. I
I
think the
believe that
question was.
Cloud Run. I think there is support for. There's not support for Cloud Run yet on GitOps, but I believe that it's on the roadmap. I believe.
Yeah, I think we already have one check in our CD pipeline, Abhinav, which is to check for the CVEs.
CV is correct.
So we have one check that is in the CD. So you will not have configuration pushed to the GitOps repo unless it passes the CVE test. But you can have more tests in that process, so that you can go and check for the automated tests, and then wait for the automated test to complete and wait for another event to kick off the GitOps pipeline further.
Yeah.
So since this is the beauty of choreography pattern versus orchestration, because everything is events driven, you can add more steps to it and have again, it's passing of the resources state, passing of the information to the in the form of an event, so that the consumer of the event will decide what to do with it.
Yeah. And one thing we didn't touch on, I think, which is important, is that Cloud Build um, is very event kind of supports lots of different types of events that can kick off a trigger. So in our case, we're using almost all of them, right? We're using PubSub from Artifact Registry. That's the event that when an image is published to Artifact Registry, we listen for that event, and then we kick off the CD process. We're also actually heavily making use of um, webhooks. So Cloud Build supports webhooks. And so that's how we're getting events from GitHub whenever there's a change to the GitOps repo. So that's also, we're making heavy use of that. So that is another way to, that Cloud Build itself supports this choreography pattern, and you can really, come up with very elaborate solutions. But the key is that this is something that we thought was simple, right? Use webhooks and PubSub in a simple way, but put it together using Terraform so that your onboarding process is very simple. And a lot of organizations, if you're a developer in a large organization, you want to onboard an application, you have to wait for the DevOps team to set up the pipeline, set up this, set up that. So this is our attempt to make that life easier for them, for developers as well as the DevOps engineers, so that they can onboard applications faster.
Well, if there are no more questions, Abhinav, maybe we can wrap the sessions. And
Absolutely.
I want to thank the audience for giving your valuable time, 1 hour, for all of those who join. And I believe the recording will also be available. So if you are not able to join after registering, you will be able to see the recording later on. So thank you very much for coming to the session and spending your valuable 1 hour with us.
Yeah, thanks. Thank you, and hope to see you again. Bye.